3. The rules of predicate logic and overview. If we confined ourselves to the rules of sentential logic, we would be unable to derive any interesting conclusions from our premises. All we could derive would be conclusions that follow purely in virtue of sentential logic. On the other hand, as noted at the beginning of Chapter 6, there are valid arguments that can be shown to be valid using only the resources of sentential logic. Consider the following valid arguments. XFXHX Every freshman is happy. FC Chris is a freshman. HC Chris is happy. XSXPX Every snake is poisonous. XSX and PXDX Every poisonous snake is dangerous. SMX is a snake. DMX is dangerous. In either example, if we try to derive the conclusion from the premises, we are stuck very quickly, for we have no means of dealing with those premises that are universal formulas. They are not conditionals, so we can't use arrow out. They are not conjunctions, so we can't use ampersand out, etc., etc. Sentential logic does not provide a rule for dealing with such formulas, so we need special rules for the added logical structure of predicate logic. In choosing a set of rules for predicate logic, one goal is to follow the general pattern established in sentential logic. In particular, according to this pattern, for each connective, we have a rule for introducing the connective, and a rule for eliminating that connective. Also, for each two-place connective, we have a rule for eliminating negations of formulas with that connective. In sentential logic, with the exception of the conditional for which there is no introduction rule, every connective has both an in rule and an out rule, and every connective has a tilde out rule. There is no arrow in inference rule. Rather, there is an arrow show rule, namely, conditional derivation. In regard to derivations, moving from sentential logic to predicate logic basically involves adding two sets of one-place connectives. On the one hand, there are the universal quantifiers x, y, z. On the other hand, there are the existential quantifiers x, y, z. So, following the general pattern for rules, just as we have three rules for each sentential connective, we correspondingly have three rules for universals, and three rules for existentials, which are summarized as follows. Universal rules 1 Universal derivation UD2 Universal out O3 tilde Universal out O Existential rules 1 Existential in I2 Existential out O3 tilde Existential out O. Thus, predicate logic employs 6 rules, in addition to all of the rules of sentential logic. Notice carefully, that 5 of the rules are inference rules, upward-oriented rules, but one of them universal derivation is a show rule, downward-oriented rule, much like conditional derivation. Indeed, universal derivation plays a role in predicate logic very similar to the role of conditional derivation in sentential logic. Note, technically speaking, existential out O is an assumption rule, rather than a true inference rule. See section 10 for an explanation. In the next section, we examine in detail the easiest of the 6 rules of predicate logic: universal out.